Beloved student, I hope all of you is doing great. And in this session, we will learn about electron configuration based on Bohr atomic model. How are the electrons arranged at each energy level? How does Bohr arrange the electron? To learn about electron configuration, you should know that there are some rules. The first rule is electron shell, kulitnya elektron, are filled from the inside out. So the electron filled from the inside, it is the inside, the shell that nearest with the nucleus, and out. Go out to the second shell, third shell, fourth shell, and so on. So electron will be filled from here, from the first cell into the outside. And the second rule, each electron shell can hold a certain number of electrons. So there is a maximum electron for each shell. Ada maksimum batas atau ada kuotanya di tiap-tiap kulit ini. Nah, the maximum follow this formula 2n square, 2n kuadrat, which n mean energy level. Jadi n-nya ini adalah energy level atau kulit-kulitnya. N sama dengan 1 untuk yang pertama, N sama dengan 2 untuk yang kedua, N sama dengan 3 untuk yang ketiga. Jadi maksimum elektronnya mengikuti rumus 2n kuadrat. Kalau kita masukkan for n equal 1, n equal 1 it means to multiply by 1 square. 2 dikali 1 kuadrat, hasilnya 2. So the maximum electron for the first cell is 2. So this shell, kulit ini hanya bisa berisi 2 elektron saja. Kalau kita punya elektron lebih, dia akan berpindah ke kulit selanjutnya, tidak bisa di kulit pertama. The maximum electron for the second cell is 8, the third is 18, and so on. So we know got this maximum electron that will be used to make electron configuration. And the last rule is the maximum electron in the last shell, or we call it electron valence, is only 8. So whenever the last shell it is, the maximum is only 8. Jadi nanti kalau elektron itu sudah sampai di kulit terakhirnya, maksimumnya itu cuma jadi 8. Walaupun jadi kulit keempat harusnya maksimal 32, tapi berubah menjadi 8. kulit ketiga, maksimumnya kalau dia menjadi kulit terakhir, maksimumnya juga 8. So it is the rule. And we will move to the example. From the first example, we have hydrogen with the atomic number of 1. If we only have 1 proton, it means we also only have 1 electron because it is a neutral atom. The number of protons that's shown in the atomic number equal to its electron. So this atomic number of these atoms equal to electron number also. So hydrogen only has 1 electron, so the electron configuration will be simply just 1 because it is just 1 electron. If we see the larger atom like boron have 5 electrons. These 5 electrons will be distributed into the first cell. The first cell got 2 electrons because the maximum is 2, so we fill the first electron first with its maximum. And then we move into the second shell. The second shell, it is just the rest of 5. So we will have 2 and 3. The 2 is in the first cell, the 3 is in the second cell. It is in the configuration, electron configuration of the boron. If we have larger atom like oxygen has 8 electrons. The first shell is 2 and the second is 6. If we multiply this, 2 and 6 is 8. So all the electrons already distributed in the first and the second shell. If we take a look at this picture, it is represent of the oxygen atom, which have 2 electrons in the first cell and 6 electrons in the second cell. It is the configuration of oxygen. So now we move to the second example. This is the rule, and we have potassium from the first example. Potassium or He have 19 electrons. For this 19 electron, we will distribute it into the first cell, second, and the third. From the first cell, we have 2 here because the maximum electron for the first cell is 2. And then we move to the second cell. The second cell only got 8 because its maximum only 8, and we still have 9 electrons. For 19 electron here, we have 2 and 8, it is 10. 2 ditambah 8 itu 10, jadi sisanya masih 9. Nah, it is like already correct, but we have another rule that mention if we got electron in the last shell, elektron di kulit terakhir, di paling belakang, berarti ya di paling belakang, the maximum is only 8. So the third shell should be have maximum of 18 electron. However, because this third shell become the last shell, yang kulit ketiga ini sekarang menjadi kulit terakhir. Kulit terakhir itu maksimal elektronnya cuma 8. Jadi angka 9-nya ini harus kita pecah. Dipecahnya mengikuti angka maksimal di kulit sebelumnya, terus sisanya ditaruh di kulit keempat. So the right electron configuration for potassium is 2 from the first cell, it's from the second cell, it's also from the third cell, and 1 for the last cell. And we have another example for iodine. Iodine have 53 electrons, and we give 2 electrons from the first cell, 8 from the second cell, 18 from the third cell. It is just like the maximum electron from the atom. And from the fourth cell, it is become the last shell. Because it is the last shell, so you need to divide, because the last shell only have 8 electrons. So it will become 2, 8, 18, 18, and 7. We write 18 here because we follow the previous maximum electron. Jadi nanti memecahnya itu di kulit yang keempat mengikuti maksimum di kulit sebelumnya. Kalau nggak bisa 18, berarti sebelumnya lagi 8 gitu. Ini karena masih bisa 18, berarti ditulis 18, sisanya. And the rest will be in the last shell, just 7. So it is just 7, and it is still correct because 7 is smaller than 8. Okay, that's the electron configuration from the Bohr atomic model. However, this Bohr atomic model is not the perfect one. We will learn the other electron configuration from the next meeting using quantum atomic theory. Now it's your time to practice, and please make the electron configuration by your own. Good luck. Assalamualaikum warahmatullahi wabarakatuh.